give answer for each of the question and the exam given in October 2022 or 2014-15. So here are the constants. You can take acceleration due to gravity 10 meters per second square, mass of the earth 6 times 10 raised to 24 kilogram, blah blah blah, and so on. Okay, today we only need to solve 5 questions. So we start from the first one. Let's say that suppose triangle object O, this object O is placed in front of a mirror. We have a mirror and its image is observed at position X. Which one of the following diagram represents the image formed by the mirror when it is observed from position X? Okay, now we are going to observe the image which is formed by this mirror. Okay, just to discuss, let's consider this is a mirror. We have such type of mirror. Let's say if you have a circle, and the image will be circle. Consider this is the object, this one is the object, and this one represents the image. And if you get a triangle, you'll get triangle. If you have line here, you'll get a line, horizontal line or vertical line like this one. So how we are going to form the image? So let's proceed to the method. We have this one and this one. Consider this line are 2 points, point A and point B. So where do we put point A? First we have to measure from this point up to the mirror. So if you have distance X, so we have to measure distance X from here. This is X, so we put point A here. This is point A, and then again we are going to measure second point, let's say from point B up to the mirror is the distance, let's say Y, so we have to measure Y distance. So from this point we need to have a line which is this one. This is point A and this one is point B. So here we have A, first A then B, but the image will be, this is the object and this one is the image. We start from B then goes to A. So likewise, now let's cross to the next one. Again, let's say we have a mirror like this one, and if you have a line here to measure a distance, then we have an image here. This is the object and this one is the image. This is the object and this one is the image. But if you draw a line in this direction, so we have to draw a line in the right direction here. So this direction and should be in this direction. So if you have another line here, so the image will be in this direction. So this is the object and this one is the image. So what is the basic idea here is you have to measure distance between these 2 points. That is the distance, we have to measure this distance, let's say X. So we have X, and if this distance is Y, from here to here is Y, so we have to measure Y distance. Then we have to put the points, and after it's possible to draw the lines or what the image looks like. Now let's proceed to the other one. So again we have a mirror here, then let's have a line first. This type of line, let's say we have this line and this is the object. So in order to have the image of this object, first we have to measure the distance as I told you before. So we measure the distance from point this up to the mirror. So let's say this is x distance. Let's say it's 1 centimeter, so we have to measure 1 centimeter in this one, the x distance. And then another point here, we have to measure a distance, let's say y, which is y is about 2 centimeter. So we have to measure again 2 centimeter. Then after, we have to connect these 2 points. So when you connect these 2 points, you will get this image. So if you have additional line like this one, parallel line downward, so we have to put parallel line like this one and connect here. So if this is object, this one is the image. So based on this idea, it's possible to answer the question. So this question, the answer for this one is C. The answer is definitely C. Okay, we proceed to the second question. Question number 2. It says that an object is placed 25 centimeters in front of concave mirror and having focal length 10, and the magnification of the mirror is. Now we have two types of mirrors. This one is convex mirror, which is converging mirror, and this one is concave mirror, which is diverging mirror. So the light comes in parallel direction, it converges to the focal point here like this. We have this line, it converges like this, it comes this way, it goes like this. So this one also a diverging mirror. It diverges the light that comes in this direction. So it diverges like this. So this one is a diverging mirror and this one. So we have to take this one in for the question. So we have concave mirror. This is concave mirror that we have. And there is a given value, which is the focal length is 10 centimeter. F is equal to 10 centimeter. And an object is placed, this is 10, and the center is 20. So an object is placed around here, which is at 25.0 centimeter. So the question is, find the magnification of the mirror. So before we proceed to that, the line comes in this direction first, and it diverges upward, as we know, diverges like this, and the other lines goes in this direction. So we have to consider this line, and this one follows the focal point. The diverging purpose is like this one. So we have to use a general formula, which is 1 over f is equal to 1 over object distance plus 1 over image distance. So having this in mind, the focal length is given, which is 1 over 10, which is equal to 1 over the object distance is placed 1 over 25 plus 1 over the image distance. So 1 over 10 minus 1 over 25, which is equal to 1 over image distance. Then 1 over 10 minus 1 over 25 is equal to 1 over image distance. So 25 is common, which is 2.5 minus 1, which is 1 over image distance. So 2.5 minus 1 is 1.5. 1.5 divided by 25, which is 1 over image distance. So SI is equal to 25 divided by 1.5. Okay, by 5, it's 5 by 5. That is 3. 0.3. So we have this one. So now we are going to find the magnification Magnification is image distance divided by object distance, which is equal to 25 divided by this number, which is 25 over 1.5. So this cancel out and we will get 1.5. So 1.5 is the answer. So we proceed to the next one. Question number 3. Which of the following statement distinguish between random and systematic error? Okay, so when you go to random and systematic error, so we need to consider 2 pointers. First one is what systematic means. Systematic, and second one is just random. So systematic and random error. So in systematic and random error, systematic actually explains about the accuracy. So it explains about the accuracy of measurement, but random error it's also precision. So these are about the accuracy of measurement, but random is only specifies about the precision of measurement. This is regarding the precision of measurement. So this can be explained by using this diagram. For example, if you have a measurement like this one, so if the measurement is placed in such form, for example, if you have measurement here, these are measurements. So this measurement is not accurate, but it is more precise. It's more precise. But if you have another measurement like this one, if you have a measurement in this form, like this, it is precise as well as accurate, because it finds the target. Target is the center, so it is more precise and accurate. But if you will like this, it's distributed in this way. Some of the measurement goes here, 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 here. So in this case, it's not accurate and it's not precise. So this is the explanation regarding accuracy in measurement. So as we know that there are 2 measurement errors. One is systematic error, the other is random error. So measurement error, we have 2 revisions. One is, and this is the first one, and this is the second one. One is systematic error, and the other is random error. So systematic error is due to the measuring instrument. For example, if you have a broken instrument like this, so this cannot measure equally. But if you have exact measuring instrument, but due to the precision on measuring, which one is the result, this one or this one, on the precision, we'll get random error, but because of this, we'll get systematic error. But this can be removed by having more data. Random error can be removed. So based on this one, it's possible to answer the question. First question says systematic error can be minimized by taking several readings. No. Random error can be minimized by taking several readings. So A cannot be the answer. Systematic error makes measured values to be always above or always below. This is completely wrong. Sometimes in systematic error, you'll get maybe above only or below only, so it can be the answer. Random error makes measured value to be always above or always below the true value. So in a systematic error, as I told you before, this one random errors is due to maybe the personality, the mood of the person. So measured value to be always is completely wrong, above or below true value. sometimes you will get exact true value in the middle. So there are systematic error caused usually to be sometimes above and sometimes below true. So random error is just biased, yeah, it's correct because of the mood of the person, whereas systematic error does not show a bias, yeah, maybe due to the instrument, broken instrument, lamp and so on. So the correct answer is D. So now proceed to the question number 4. It says that the unit vector, we have this unit vector which is equal to 3 in the I plus 4 in the j. So find the unit vector. Unit vector can be calculated as a vector divided by its magnitude. So first we need to find the magnitude. So magnitude of vector A is equal to the square root of 3 square, 3 in the I plus 4 in the j, which is 4 square. 3 square is 9, 4 square 16, so we get 25. Square root of 25 is 5. Therefore, the unit vector is equal to vector A over magnitude of A, which is equal to 3 in the I plus 4 in the direction of j divided by 5. So this will be equal to 3 over 5 in the direction of I plus 4 over 5 in the direction of j. So this is the answer, which is A. So when we proceed to question number 5, it says which of the following pair of vectors are collinear. Collinear, they are like this one. So okay, collinear means in the same line. In this, okay, so let's first take the first one. It says 2 in the I, 3 in the j means we have the x-axis and y-axis. This is 2 in the I and minus 3 in the j, minus 3 in the j. So this line is this one, just like this. So we'll compare it to minus 4. Second one is, it says B size minus 4 in the I, and say this is minus 4 and minus 6. So this is not, these two lines are not collinear. So let's proceed to the second one. It says B, it says I plus j, I plus j. I here is I 1 plus, this is 1 in the positive direction, this is line, and but the second one is minus 1 in the positive and positive 1. So these two lines are not collinear again. B is not the answer. And C besides 2 in the I, it's 2 in the I and 3 in the j. So this is a line, and minus 4 in the I. This is minus 4 in the I, and positive 6, and it's positive 6. So these two lines again is not collinear. This line and this line are not collinear. So let's proceed to the second one, D. 2 in the I, here is 2, 1, 2, 2 in the I and 3 in the j, 1, 2, 3 in the direction of j. So connect these two, get this line. And minus 4 in the I, 1, 2, 1, 2, 3, 4. This is minus 4 and minus 6, 1, 2, 3, 4, 5, 6, 7, 6. Yes, connect these two and you get a line like this. So they are collinear. So the answer is D. That's enough for now. We'll proceed from question number 5 in the next